All right, here we go. So 3.2b, even and odd functions, okay? As far as your 3.2b assignment goes, your 3.2b assignment is more so of creating the functions from 3.2a. I had to just try to figure out how to divide it, so I would only use 2 sheets of paper because no, I just didn't want to waste more paper. So but anyways, so you're gonna need both set of notes to do the 3.2b assignment, basically, okay? Yes, the one that's 2 started. So here we're going to talk about our symmetry. So when you did your parent function projects, you had to tell me what type of symmetry it was, right? If it was even, y-axis, all that good stuff, right? So what we're going to do is kind of remember exactly what that meant. So when you have y-axis symmetry, that literally means that the y-axis evenly divides the function. Do we see that? So physically, it's even, the y-axis is evenly dividing the function. When you're looking at a table, what that means is that if I have 1, -3 on the table, I also need to have -1, -3 on the table. Okay. So what's happening is that your x's are changing, but your y's are staying the same. Does that make sense? So my x's change, and mathematically we show that there's a change by making it a negative, and my y's are going to stay the same. Okay, so a function that has a y-axis symmetry is an even function, so we call it even. Okay, now origin symmetry, rotate, or sometimes called rotational symmetry. What it means is that the function or a discontinuity of the function goes through the origin. So it goes through the origin, hence why it's called origin symmetry. Okay. And so it's going to go through the origin. And when you're looking at it, it has what we call, it can be rotated. So I'm going to do my very best to trace this and show you the rotation, but it's really hard. So bear with me. I'm concentrating.
She's a little wobbly. See, she wobbled.
All y'all are annoying. Here we go. So here's the function. The ones who didn't make comments, thank you. If I rotate this 180 degrees, the function is still going to be the same. Okay, that is what, that is what origin symmetry means, is that I can rotate the function 180 degrees and it's still going to look the same. Okay, so when you're looking at the values, that means that not only is your x changing, but so is your y. So notice here we have +1 and +1, and here we have -1 and -1. Okay, so that's going to give us a change in our x and a change in our y. And when this happens, a function whose graph has origin symmetry is an odd function. Okay, in terms of polynomials, that means that this has an even degree and this has an odd degree. Makes sense? Okay, y-axis symmetry means that you have an even degree polynomial. Origin symmetry means you have an odd degree polynomial. Okay, last but not least is y-axis symmetry, x-axis symmetry, I'm sorry. If you have x-axis symmetry, that means your x values are staying the same, but your y values are changing. So x is the same, y is changing. If your function, if your graph has x-axis symmetry, it is not a function. Can someone tell me why it's not a function? Your x repeats, and can your x repeat? No, it fails the vertical line test. So it fails the vertical line test. Okay, at this point, how do you feel about graphically being able to identify whether a function is even, odd, or neither?
Good now. Good.
Graphically, you're good? Okay. Yes. Okay. Because there's multiple representations of functions. We have graph, tables, and expressions, or algebraic, however you want to think about it, right? So we just did the graph. Now we're going to do a table. Are you with me? Okay. These are the rules that you have to follow when using a table and an equation, okay? When you're analyzing the table, you're looking to see if the original function equals its opposite, meaning that instead of having a positive x, I'm going to change all the x's into a negative x. And if I do that, do I still get the same result? If I do, then it is even. If I don't, then it may be odd or neither. Okay? All right. So here we go. Starting off with a table, we're going to start off very simple with f of x equals x squared. Okay? Right off the bat, if I look at this as far as a polynomial and its degree, what is the degree of f of x? What is the degree of x squared? So it's a second degree polynomial, right? Because it's a second degree polynomial, that means in theory, I should already know that this is possibly an even function, right? Because my degree is even. When you're analyzing the table, in order for it to be even, your f of x has to equal your f of negative x. So these two tables have to be exactly the same when you're plugging in the values, okay? If it was odd,
Sorry, I'm writing on my notes.
some people can't be distracted. Okay, if it's odd, then these two tables will be the same. Okay, even, your original table and the opposite x will be the same. Odd, the opposite x and the change in your y's will be the same. If it's an even function, these two tables will look identical. If it's an odd function, then these two tables will look identical. Okay, so when I plug in -3 into x squared and -2 and -1, I'm going to end up with 9, 4, 1, 0, 1, 4, and 9. Agreed? Okay, when I come over here and I do the same, I'm going to plug in -3 into -x squared. Well, a negative times a negative is going to make it a positive anyway, so it's still going to repeat 9, 4, 1, 0. 1, 4, and 9.
Even.
Okay. Now this one is a little different. This is saying you're still going to square it, but after you square it, then you change the sign. Does that make sense? Because you're following PEMDAS, and PEMDAS says to deal with my exponent and then I multiply. So I'm going to deal with my exponent, then multiply by -1. So -3 squared is 9, but 9 times -1 is -9. -2 squared is 4, but 4 times -1 is -1 squared is, and -1 squared is 1 times -1 is going to give me -1. And this is going to repeat all the way down. Okay, so when I'm comparing the tables, I'm trying to figure out which two tables are the same. Well, the two tables that are the same are my original and my change in my x table, my -x. And because those two tables are the same, that means that this is a even function. So f of x is even, and that's because f of x equals f of -x. Which means my y values stay the same. My x values change, right? Even though my x values changed, my y values stayed the same, okay? So that's what you're doing. You're analyzing two tables and determining whether they are odd, even, or neither. Okay, now we're going to talk about it algebraically. Algebraically, you're going to always find f of -x. That's step one. But if you're comparing even, you don't have to go that far, but you're going to always find f of x, f of -x. So I'm going to start off with finding f of -x. Okay, if I'm doing f of -x, that means I'm doing what? substituting a negative in for the current x. Does that make sense? So this equals negative x to the third minus 4.
Oh, I see. I get it.
Where's the negative?
Jinx. Stop.
That's the first thing you do is you're going to find f of negative x. So that's showing if I change my x values, how is it going to affect my function? I think you don't because you missed a part from the table earlier.
Oh, no, I'm sorry.
Yes, sir.
What do you say?
Here's our-
Oh, maybe we should consider moving it closer to the front.
No, I got it.
Okay.
This here is fine.
There's a table where no one sits, and if you get easily distracted and confused, it may be helpful to be closer.
No, I'm good.
I am. Here we go. So we have negative x to the third minus 4. So when you have a negative times a negative times a negative, the ending result's going to still be a negative. Uh-oh. Okay, so you can test that it's odd by saying, is this and this the same thing? Even, I'm sorry.
No.
Are those the same thing? No. So that tells me that this is not even. Because this and that are not the same. The original and the f of negative x are not the same. Yes.
Oh, wait. Are we still comparing the two? Like this one and that one?
What's underlined? So you're comparing the original to this.
I'm saying like the table, like last one. we compared
Yeah.
2 and 3.
So now we're gonna do the third column. So we did these two together and they weren't the same.
So if you find out that it's not negative, I mean, not even, can you just say that's odd?
No, you have to
Mm-mm.
compare it to the.
You're gonna compare it to the last one. So now we're gonna do negative f.
And then if that one doesn't match either, then it's not.
Then it's neither, exactly. It's a function, but it's neither even nor odd. Okay, so the first, now we're gonna do the second. The second table was your negative f of x. When you have negative f of x, that means you're changing the entire function. Does that make sense? So negative f of x means I'm taking a negative and multiplying everything in the function by that negative. So when I distribute, I end up with negative x to the third plus 4. And now I'm going to ask myself, is this and this the same? And the answer is no.
Why are we comparing it to the first?
So think about our two columns in our table. This is table 1, this is table 2, this is table 3. So if table 1 equal table 2, then it was even and I would be done, right? But if table 2 equal table 3, then it would be odd. And are they equal?
No.
No.
So they're
Neither.
neither.
So it's neither. So it's not odd, it's just neither. It's still a function, it just has no type of symmetry. It's a polynomial function, you can see that, but it has, it is neither even nor
That
odd.
goes to the x to the 0. And this would consider a 0 that even.
Why is it neither, are you
Like,
asking?
even functions are always like. Wait, hold on.
So I'm
Even
confused
functions
between-
are always like, if it's like x to the 4th plus x to the 2nd, then it's an even function.
Oh, you're saying because it goes through, it's on the
So
y-axis?
since it says plus 4, and it would be plus 4 times x to the 0. And x to the 0 is even, and you can't mix the two together. It's neither.
Yes, but you don't want to test every single function, every single possible number in your domain. Did you say 4?
That's not.
What
No,
did
I
you
mean,
say?
Since it's negative x
Oh,
plus
video,
x plus 4 times x to the 0. Like you can consist.
Here we go. So now we're gonna test this one. So again, this is f of x equals the absolute value of x. So the first thing we're gonna do, again, you're gonna test the f of negative x. So if I'm testing f of negative x and x, I'm gonna plug in absolute value of negative x. What's gonna be the final output here? What happens when you take the absolute value of a negative? It's still gonna be a positive, right? So before we go on, we ask ourselves, does my original equal this?
Yes.
Yes, so guess what that
So
means?
we're done.
It's an even and we're done.
I got a feeling you're gonna put the long one on there.
I do too. It's only one evening. 15 meetings.
It could be an odd.
Oh, that's so much. No, that's two, no.
Remember like 3 meters in a row, so we feel like we're moving.
All right,
No bull. Don't give me ideas. No bull, man. No bull.
here's our first. So again, the first thing you'll always check is the f of negative x. So I'm gonna plug in a negative x wherever there's an x. So we have negative x to the third plus negative x. When I clean this up, this is gonna end up being a negative times a negative, which makes it a positive. So we have x to the third, and this is minus x. So we ask ourselves, is this and that the same? No, so we know it's not even. So it's,
It's gotta be on.
It's gonna be easy.
okay, so now you're ready to the second thing. The second is finding your negative f of x. Negative f of x means that you have a negative times the entire function. When you multiply an expression by a negative, all you're doing is changing the signs, right? So this is going to become positive x to the third minus x.
I knew.
Is this and this the same? Yes, so what is this?
Oh.
It's odd.
Yep.
I mean, we clearly had to do an example of all three, guys.
Yeah, that's what I was saying, you're up.
So odd is like.
I bet
when,
you that's what you like that.
when, negative s,
Sorry, you're
X.
Equal the same, exactly.
Oh, how do I do?
Just take your sticker. Yeah, your-
Okay.
I can get one.
So if neither one in either situation is equal, so if the original doesn't equal the negative x, then it's not even. If the negative x doesn't equal the negative f of x, then it's not odd, so it's a
Neither.
neither. If the original and your negative x are equal, then you have an
Even.
even. And if your original, not your original, if your negative x and your negative f of x are equal, then you have an odd. That is how it works algebraically. Oh, well, we're moving out of reteaching you the same stuff over and over, so. Huh? What'd he say?
Don't get bored of things.
I don't know what Sam said,
Sam said he tried this bull crap too.
so. Yeah. Here we go. What you're gonna be doing for the rest of the period is you're just gonna be creating the other half of the function that is asking of you. And then determining whether, other half of the graph, not the function, then determining whether it's a function, and if it is a function, is it even, odd, or neither. After you do that, then you're going to work on your assignments. So really quick, for example, this says it wants me to create the other half of the function so that it has x-axis symmetry. So if I want x-axis symmetry, that means I'm reflecting the points over the x-axis, right?
That's easy.
And then I'm describing what I have. Is this a function? No, it is not.
Repeat.
The x's repeat, so it's not a function. Okay, so therefore, since it's not a function, it is neither even nor
Oh,
odd. Okay, so that's what you're doing. As you do the 6, 7, 8, 9, 10, you're gonna check with your peers to make sure you understand what an even, odd, and neither graph will look like. And also making sure you understand what a function is not, okay? After you're done, let's look at your assignment. So remember, I tried to tell you that most of your assignment is really using the notes from Friday, because it is. You need more practice with this than determining whether something's even and odd. Let's just be honest. So when you're going through here, remember, if it's already in factored form, you're identifying the zeros and their behavior. Okay, so you're identifying the zeros and the behavior. So here we have x, right? Because 5 is just my what? My a, right? So we have x and we have x minus 1. So where are my zeros at? At 0 and +1. Okay, so we're at 0, and I'm gonna call this 1 and positive 1. What degree of a function do I have? If you still can't figure it out, then you can expand.
Third.
I have a 4th degree
Four.
polynomial. I have 1x here and 3x's here, which is gonna make it 4. So I have a 4th degree and my a is positive.
Oh,
So I know I have to start positive and end positive. So I'm gonna start positive. It's gonna be a little flat, and I'm gonna end. Can someone say, why did I go through these points?
zero,
Oh,
zero.
because, what's that thing called right there?
The power?
Yeah, no, oh, if that's the answer.
The reason why you go through the point is because the power of your zeros are odd. Okay, the power of my zeros are odd, and I go through odd powers, and we touch on even powers. So if you go back and look at our notes, let's go back to Friday. Pew, 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 pew. Here we go. So looking back at our Friday notes, here they are. Lock in right now, and you'll see why. Okay, so we look back in on our Friday notes. Notice how we realized that this was a 3rd degree polynomial, and it was positive because our a is positive. So we have to end negative, start negative so we can end positive. We identified our x's. We had an x at 0, an x at 1, and an x at -4. Okay, all of them have a power of 1, which is an odd power. So I just got to go through each point and end how I'm supposed to end. Okay, here, this is an example of a even power.
Oh, okay.
We had x minus 2 squared. So I didn't just go through it, I had to touch it. So I went through 0 and I touched that 2 and I came back up. Okay. So this is what you're doing. Find the rest of 3.2b is using these notes,
Which notes are those?
3.2a
What?
from Friday.
Whichever gives me more energy.
Okay. So finish out your graphs, check with your peers, and then begin making your actual graphs. Okay, notice how I said no Y scale. That means I don't care. Just make sure you're understanding the end behaviors and where your zeros are. Okay.
Got it.
Oh, I got it.